Welcome to the second day of the EasyBuild user meeting. We're starting off today with site presentations. I'm going to hand over to Alan to give a presentation from his new site.
Yeah, hi everybody. So you probably all know me from my time at ULIC Supercomputing Center. So I just finished my contract there at the end of last year. And I'm actually between jobs right now. I'm due to start in my new position next week. For me, there's a lot of interference. I'm hearing a lot in my ears. I don't know if that's coming through for everyone else. Is that from? Yeah, that's better now. Anyway, yeah. So I'm due to start my new position, hopefully next week, for working for CECAM, who I've actually been working with for the last 5 years. On a European Center of Excellence project as well, so I'm quite familiar with them. To tell you a little bit about what CECAM is, it's actually a network. So it's a network of excellence in simulation and modeling. The French term, if you'll excuse my pronunciation, is Centre Européen de Calcul Atomique et Moléculaire. So basically, it's been around for 50 years. It's always been about computation, and now the activities have always been expanding, but they're growing ever larger, right? The amount of things that the amount of subject areas that they cover and the things that they're involved in. It has a lot of scientific institutions involved and an awful lot of researchers who are involved in their program of activities. Work a lot on things like methods and algorithms, and like I said, there was a big project, an HPC Center of Excellence, so they do a lot on the HPC side as well. And it's all about cutting edge algorithms, cutting edge applications, and the cutting edge of science in general, in the areas that they're interested in. So like I said, it's been around for about more than 50 years now. The birthday was probably a couple of years ago now. And it's made up of it's a nodal structure. So it's made up of 17 nodes, and they're in 10 different European countries. They all have their own kind of local funding, but basically the funding is gathered centrally through partner institutions who provide the funding, and then that's distributed again to the nodes. So the nodes have their own money to work from, and then there's also central money that funds the headquarters. So the headquarters is actually in CECAM. CECAM headquarters is in EPFL in Switzerland. It hosts a large number of activities there, and that's where the director and Sarah Bonella, the vice director, is located. And so they have a lot of different things that they carry on there. But the main programs of things that they do are workshops and schools, lots of online events these days, like everybody else. And then they have focus groups and activities that are in topics of emerging interest. So looking at topics that are of interest to a lot of people in the community, and then talking about what exactly is going on in those areas and where the future might lie, and to discuss collaborations and also with industry and everything as well in those topic areas. As regards the number of events that they have, so in the network itself, so among the nodes, they have maybe 50 to 70 events per year. And then at the headquarters in Switzerland, they'll have up to 18 events. And those are, like I said, have been funded by the partner institutions. So at the headquarters, you would get about 700 participants per year. And at the nodal events, you're talking about 2,000 in total. So you'd have 2,000 people participate in these events every year. It covers an ever-growing range of scientific areas. So there are ones that were covered in ECAM, the HPC Center of Excellence. So that was electronic structure, classical MD, and it was also quantum as well. And then there's lots of different areas that are also covered in here, or that come under the umbrella of, say, CECAM. And many of those you'll probably be familiar with, especially they're quite trendy these days, things like quantum computing and machine learning as well, and how they appear in science in general. As regards the workshops, so all the workshops are about this cutting edge of science and of research. So they address the open challenges. They're meant to be like medium size, and the idea is that they promote idea exchange between people. So they're usually about 3 days long, with lots and lots of space for people to discuss, right? So they're usually not too big, usually like a medium-sized number of people, but it's usually with in-depth discussions. The schools are a little bit different. So the schools are more oriented towards teaching, and that's at the kind of the graduate and the postdoctorate level, right? So it's a kind of like skills development for people, for researchers in the area. And then in the graph on the right, you can see what's the split like between these different types of events, between like the nodes and the HQ itself. There are alternative formats that are covered. So they've had different kinds of things. They've had visitor programs, they've held conferences, they do recurring events sometimes, lots of focus meetings. And now, of course, there's lots of online and hybrid meetings, and a lot of the events that are held by CECAM are recorded and available online. And then there was something called software development workshops, which we had in the HPC Center of Excellence, which were either week-long or even multi-week workshops, which were designed solely for helping people with software development. And usually there was a lot of HPC relevant material in those kinds of workshops. So where does the link with EasyBuild come in? Well, probably through me a little bit, but also there was a paper that I was an author on that I contributed to that came out last year that was talking about approaches or to what kind of could be done or should be done, especially in the electronic structure space, about instead of having monolithic huge packages that are very difficult for new researchers to get involved in, but to actually break that down into building blocks. And so when you talk about building blocks, that means dependencies. And when you talk about dependencies, then EasyBuild in the HPC space, EasyBuild was a good solution for them. So that's mentioned heavily in this paper. So where do I come in these days? So more it's kind of a side project that I'm interested in, something called Learn HPC, which is about providing clusters in cloud environments. And then it's kind of three related things really. So the clusters in the cloud, that's done through Magic Castle, and software that comes on those clusters comes through Easy, which is also relies heavily, of course, on EasyBuild, and you'll hear more about Easy this week. And then as regards the lessons that are taught on those clusters, the philosophy would come from the carpentry, so software carpentry, and there's something that I've been contributing to called HPC carpentry, which we would like ultimately to become an official part of the carpentries, which is this idea of shared material, shared training resources, right? So material actually to train on these kinds of cluster. And basically to date, we've had resources that come through the Phoenix research infrastructure, so that's European infrastructure to support cloud-based workflows, and also some sponsorship from AWS and Azure as well. And that's basically what I'm doing with these workshops, is to try and provide this kind of support to them. So this kind of HPC related support. So give them access to machines that they can use within the many events that they hold. Why cloud-based clusters? Why not the real thing? Because real systems come with very strict security requirements usually, and lots of bureaucracy. And certainly for beginners, these can be quite intimidating and can kind of really delay the learning curve quite a bit. And the reality is that it's not so easy to get these kind of courses all over Europe, especially when you're talking about a lot of events. And because, well, if I think about my former employer, right, German HPC Center, could you seriously consider running training courses for arbitrary in number and arbitrary in terms of the European institutions and even companies that are involved? No, that's not really a realistic proposition. And the nice thing about cloud-based clusters is that they're unencumbered, so you can bring them up, take them down, and throw them away. That's all okay. And you can agree in advance that it's purely training-based. Nothing is meant to be secure, right? And you should be aware of that. And they don't have to be toys. You can have InfiniBand support. You can have on AWS they have their own fabric called EFA. So you can also support that. So you can have a fast interconnect, and you can have GPUs. There's plenty of GPUs in both Azure and AWS and in many of the cloud providers as well. You can get this. You can have scalable file systems as well. So for example, Lustre, you can either build it yourself, or there are offers from the various providers that can serve that kind of a need. And the nice thing about cloud clusters is they're reproducible, and reproducible in this case does mean scalable. So you can have multiple different clusters, and they can be event specific. So, and that's very interesting for us because that means we can organize events and have event specific clusters. And that's basically where we are right now. I haven't actually started working for them yet. And so that's the plan for the next year or so, at least, is to start putting all this infrastructures in place and to support the event program within CECAM. Thank you.
Hi, does anybody have questions for Alan?
That's probably not a bad thing. I mean, I don't think I said anything too controversial anyway so far. So
yeah.
And if I may jump to Alan, so which is the relation with the Center of Excellence with so are you developing or are you fostering the usage of any tools like EasyBuild for the members, or what are you, is there a relation or?
Well, so I think one of the plans that I would have going forward is this. So this EC project that you'll hear about more about this week, is that we would probably support, or I would support, the software stack from the CECAM community inside that infrastructure. So rather than teach them how to use EasyBuild, we just give them the software instead, right? So all the things. So my what I would see as part of my role in the future is to support people to get software inside EC. And once they have software inside EC, then they can use it, whether it's in the cloud, on their own machines, or on HPC resources, it'll be there. And the nice thing about that is you know, they're reasonably frequently there are updates, and within EC, those become somehow transparent. They just appear on your machine all of a sudden, and you can load the latest version of whatever package it is that you need. So for people who, especially for people who do things like workflows, or, you know, who this kind of thing, it'll be very helpful for them, I believe. Right, because they will just work out of the box, which is great. They don't have to do installations themselves, and also they, you know, it'll be a lot easier, I think, to define workflows using tools like that in a scale, in a way that where those workflows are actually perform, right? They actually have good performance.
Thank you. Yeah, I think you will see. I would mention things like this, but I think we will have room to discuss the next weeks regarding all these topics. Thank you.
I'm not seeing any more questions, so we'll thank you to Alan, and we will pass on to the second site presentation. Kim has asked a question. Alan is actually up next from the Barcelona Supercomputing Centre, the Earth Sciences part.
Yeah. So let me share. Okay. So can you see my screen?
Yes, we can.
Yes. So should I start, Simon, or we'll wait until 15? So I start right now or wait 2 minutes more? I don't know, to follow the schedule.
I think we're good for you to go now.
Okay. So thank you very much. I'm Kim Serradell. I'm head of the Computational Earth Science group at Barcelona Supercomputing Center, and today I will talk about our experience on using EasyBuild. You will see that it's quite a different presentation in the sense that, yeah, already says. So yesterday that there is a very advanced usage of EasyBuild, and in our case, I would say that we are heavily using EasyBuild, but not in a very fancy way. But I think it's also a nice user case. So first I will explain who we are, why we are using EasyBuild, and something that also was said yesterday by Kenneth is to show an example on how EasyBuild and the science that tools like EasyBuild are enabling. So I think it's important. I will show how we use our workflows in Earth Science and our usual typical way when submitting experiments and running simulations. So first, and this is quite important, I want to it's a disclaimer. This presentation is based on Earth Science experience. We are a research department of Barcelona Supercomputing Center. I will go further in next slide. And in fact, it does not reflect any view or strategy from the operations department, who are the managers of Mare Nostrum 4, any other HPC, and the forthcoming Mare Nostrum 5. So this is a user presentation, and I think it will be a nice example on how users that are not administrating any HPC can use EasyBuild to get flexibility to deploy what they are, the workloads and workflows. So as you may know, BSC is managing the Mare Nostrum 4. Probably, we hope that in the next, during the year or next year, we'll have Mare Nostrum 5, as well as, and this is important, other machines. We have a Power9 machine, we have virtual machines, we have the ARM and AMD clusters. So in this ecosystem, it's very nice to have this kind of tools to manage this myriad of systems. BSC has 4 different research departments. We have computer science, we have life science, the case department, which is the engineering, and we have the earth science. Everything on top of that, those departments, we have more departments like the management department or the operations department, which is the one dealing with machines and infrastructure. Earth Science Department, I would say that we are users and we work in collaboration with operations, but also we are working in our own, because you will see that in our specific case, we are not only working with our HPCs, but we are deploying in other machines, not external at BSC. So mainly what we are doing is we are doing research and forecast on air quality and on climate, and then services that we deliver to customers, that it can be private contracts, but also administrations and stakeholders. So this is quite important. You will see that because we are doing operational forecasting in the sense that we are running, for example, forecast in a daily basis, but we are not an operational center operating 24/7 with people on site there and reacting if there are any issues with the workflow. And you will see that it's quite important then to adapt and try to perform the same without really being an operational service with those amount of resources. And EasyBuild can play a role in this flexibility and this way of working that we need to implement. So why using EasyBuild? We have a different, as we were mentioning, we have workstations for our users. We have virtual machines where we start our forecast, and we have different HPCs. So you can see that it's quite heterogeneous, and then we are working mainly to produce this kind of outputs. This is, for example, an output of the air quality system that we are running for the Catalan regional government. We are running an air quality simulation daily for Europe, for Iberian Peninsula, and for Catalonia, our region. So we need a tool that can make work them together. So in the sense that we need our users are developing, for example, post-processing workstations, and we need to easily deploy those developments from these workstations to HPCs, or in the same way, if once it's in production, we need to put it here and from workstations to the virtual machine. That means that it's not only important to move developments, but also the software stack where those development has been performed, so that we are able to replicate environments. As you may know, there are tools for this. We could talk about containers and so on, but we prefer, we took this decision of using EasyBuild. Which are the main functionalities that we like from EasyBuild? So as I was saying, the reusability, users can develop on their workstations and then run on HPCs. If you are able via, obviously here there is very important, the modules. If you are able to deploy the same software stack or very similar with modules, it's very easy to have the same scripts, whatever that you can run in one place and should perform, and this is always conditional, should perform identically in other environments. Stabilities, the stability, this is important. We are doing operational forecasting and we are running the same or the very similar simulation, only changing the initial conditions daily. So we need a very stable and freezed environment. Only a change, for example, something that we have been putting a lot of effort is on Python packages. If you do a massive update with dependencies on pip, you know what happened, that then you can have unexpected results and then your forecast crash. So we need we want to avoid these kind of things. We need reproducibility to have a clear picture of the environment that we are using to produce data when we deliver. If there are issues with the data, we need to know how has been done this. And very important, we need to, in deployment, it's very important how EasyBuild can reduce the time when entering a new cluster. If we have a set of EasyBuild, of easy configs prepared with our needs, it's you will see the example of entering, deploying EasyBuild, deploying things and reducing the time to get solution. Also, because we have flexibility, we were discussing that at BSC we have different architectures, so we can with EasyBuild we can have receipts that will be deployed in each machine, but at the end we can unify somehow the software stack. And very important, and yesterday was mentioned also by in the State of the Union, it's very important to reuse and share the easy configs. So all these things of finding these kind of packages and users that already did the work for us, it's very important to reuse it. So our current installations here is not really fancy, and I'm a little bit ashamed to show that we are, for example, using 2015. This has an explanation. We wanted to upgrade with this 2019, but we had, due to COVID, it was in our workstations. We need to work physically, and this has been delayed. We still don't know how we won't be able to update it. We have an Intel cluster Nord 3. We have Power 9 now also with CUDA support. And for example, we moved to a machine from the Spanish Meteorological Agency called Cirrus, and we could deploy very fast their EasyBuild. And the same for the cloud. We are working with cloud providers in the context of different projects. So we did this exercise and we deployed EasyBuild in Huawei or Oracle clusters. So now to explain a little bit how we work, our main tool is what we call the workflow manager developed in-house called AUTOSubmit. And AUTOSubmit, what it enables is to automatize our simulations. We have in addition to GitLab, our source code is stored in GitLab, and then with AUTOSubmit, we can configure and deploy workflows that will run in different machines. We only need to change the configuration file, and then the simulation can run in any other platform. So, and it's very decoupled. So in this sense, we can have all our models prepared, and we only need to change the platform, and it will run in every other machine. And then also we put a lot of effort. This is less important, but this year we put a lot of effort in a web GUI, because it used to be only on terminal. So here is when it enters. So what I was explaining, I don't know if you see my mouse, and we have in GitLab for the source code, what we call the auto models, the templates. Here we develop and we check out, and running and using AUTOSubmit, we run in, for example, in a machine like Mare Nostrum. Then in this sense, when it's finished, the simulation, we publish it in our databases for the community. And here, and we are also using a Jenkins server to do continuous delivery and reproducibility. Where it sits EasyBuild? EasyBuild, it's really tied to the model configurations that are in what we call auto models in our GitLab. So we define there all the modules that are mandatory for a system to run. So in this sense, when we are, something that we saw that is really working for us is that when we arrive to a new machine, first we access the machine, we deploy EasyBuild. All these steps are the user can do it. We deploy our usual software stack, GCC, OpenMPI, NetCDF, SMF, and Python and R. All these packages are fully maintained by the community, the EasyBuild community. So usually it's quite out of the box to do those deployments. We deploy our workflow manager, what I was saying, AUTOSubmit, the auto model, which is how we run the model, templates with modules that we know that we just installed previously, and we run the model. This is really in applying this workflow. For example, this summer, when we access in this new INUITS cluster called Cirrus, in less than 2 weeks, we were running simulations to validate the results. So for us, it's quite good outcome to be able that in a few days we arrive there and we have results, and with minimal interaction with local sysadmins, where unfortunately it's depending on the way that this user support is organized, where you can lose a little bit of your time. As I was mentioning, we are running also EasyBuild in the cloud in collaboration, and that's why I wanted to mention with HPC now that it's also a user of EasyBuild. We did a proof of concept and in Oracle Cloud, and we have been able to port our atmospheric chemistry workflow, the model, to the cloud. And this is our idea on how we will overcome the fact that we are not a 24/7. So if Mare Nostrum, for example, is not available on May that we will start this, we will have a cloud instance in the Oracle Cloud that we will use it to run the model in the days that we cannot run in Mare Nostrum. Is the way of more or less covering this user case of always having results, although there will be also always the user intervention to move workloads from the usual Mare Nostrum to the cloud. And now to finish, things that we realized that we need to improve, we need to update tool chains. Yesterday it was mentioned which are the policies, and this is interesting, people, and in our case, we are maintaining modules until the end. How we will do this purging of all modules, it's always, you have always fear to break something that we tend to do it, and we should do it much more. It's sharing develop custom easy configs for Earth Sciences tools, and this is quite personal, but a little bit more involved in the EasyBuild community. We are getting a lot from EasyBuild, and I think it's fair to be a little bit more involved. So we will update some of our tool chains in the future. We will continue to use EasyBuild, and yeah, and I think in the future there is room, for example, in projects like Easy to work together, and yeah, and we are already discussing with Kenneth and others a possible role to play. So thank you very much. Hope you enjoy it, and if you have any question, I can take it.
If there are questions for Kim, then and you're in the Zoom, then please raise your hand and we'll allow you to ask them. Or if there are any people watching via YouTube, you can ask via the Slack, and we will also raise the questions for you.
Kim, there was one question in the Slack, so it was about risk 5.
Yeah.
Basically, there's a lot of activity at BSC related to risk 5, and we were just wondering, or Kenneth was wondering, like, is it relevant enough for you in the near future that you're looking at that
Totally
at the moment?
See, totally. In the framework of other projects, for example, one FED project that we conclude, Escape, we are working on what we call dwarfs. So usually our models are really a monolithic million lines of codes, really difficult to port. In that project, what we come out, it's what we call dwarfs. So small kernels, for example, most descriptive kernels like the microphysics, the advection, and radiation. So we isolate it with an input and output. And it's this very nice exercise because now with this small dwarf, it's much more easy to port to experimental architecture like RISC-V. What's the main issue in the current status? That RISC-V, the Fortran support is quite reduced. And our codes are mainly on Fortran. Yes, it's a pity, but I think long life to Fortran. And we have I think only 3 dwarfs with C or C++. We are working with RISC people on them, but I also know that they are putting a lot of effort to support Fortran codes. So we hope that in the next year or month or years, we will be able to start running some of our Fortran dwarfs in RISC-V.
Now a question from me. So then do you use the LLVM compilers much? So are you looking at the development of Flang and things like that? I imagine that will probably help there.
Yes, I know that they are, but I think that for more, I'm only on RISC, I'm only on RISC-V, I'm only on the user side. So for questions, I think you have a presentation from John Davis in the last day of the user meeting. And I think he's the right guy to ask, because I'm only on this part of executing and the guinea pig of going with our codes there, and everything is crashing and we need to work a lot together. So
maybe just a comment from the EasyBuild side. We're keen to start working on RISC-V support.
Yeah, so me too. And yeah, I think I will contact you. I'm already discussing with Kenneth, but there are initiatives that right now I cannot give much more details, but the Earth Science community, the HPC Earth Science community is really keen on working on that. So I think the connection with EasyBuild could be really, really interesting. So I probably will contact in the next weeks. So.
Passing across to a question.
Yeah, hi, can you hear me?
Yes.
Yeah, it's not really an EasyBuild question. I was just interested in your AUTOSERV framework.
Yeah.
How generic is that? Is that very tied to the kind of stuff you're doing, or could it be applied more generally?
It can be applied. It could be applied to any workflow, in the sense that we are now, any workflow with HPC needs could be run. At the end, what we are tied is that we are offering features in the workflow that are really needed for our kind of workflows. I'm meaning that we are running what we call complex workflows with what we call, for example, for decadal experiments with different start dates. So these kind of things we are supporting. And in other workflows, because there are a lot, and we did also already the comparison, for example, only on Earth Science, you have EasyFlow, you have Silk, and you have AUTOSUBMIT, the more known than external. But yes, but our workflow can support, I would say, any workflow to run on HPCs or any machine. And we would begin, we have, I can give you the contact, and we have everything is published on PIP and so on, so you can take a look.
Okay, thanks.
Did anybody else have any questions? I'm not seeing any, so I think thanks to Kim for that presentation. Our third site talk of today is from Dennis from the INUITS group.
So hi, I'm Dennis, and today I would like to take the opportunity to introduce to you the firm that I work for called INUITS, and how exactly we develop and help develop software EasyBuild together with in cooperation with UGent. So this is what we're going to talk about, a little bit of who we are, what is the workflow on in terms of working on EasyBuild. So first of all, we INUITS, we are software developers, researchers. We love open source. We like to call ourselves open source innovators. And also we provide some consultancy services. As of now, we have seven offices in 4 states: in Czech Republic, Poland, Ukraine, and headquarters are in Belgium. Well, so we have been working with UGent since 2019, and we decided to work with UGent on EasyBuild mainly because we love open source, as I said. So that was really appealing point for us. Also, it was the range of skills that is required for developing such a complex software is very challenging. So that was also an opportunity for a little bit of growth in our ranks. And of course, university cooperation is quite a unique opportunity which we wanted to take. And why UGent needed us in the first place was because they had to because they needed some extra workforce for developing support for softwares in EasyBuild. More on that later. So what we actually do, we usually get well, we have this GitHub repository called EB-INUITS, which we share as INUITS with UGent, and then there we get some requests from researchers, and these requests are about supporting new software or new versions of software by EasyBuild. So we take a software and we try to install them and then put it in an easy config, and debug anything that might just come along the way. And what is quite important is to say that we usually work on new software requests, so not just updates, which tend to be a little bit easier, but our main focus is on new software requests, which, if you think about it, are still more and more obscure and difficult, since the main software pieces main software pieces which are pretty much ready to be reused in universal tools such as EasyBuild are already like taken, let's say. So the smaller the software is, the more challenging it can be, and that's what we usually work on. So yeah, we usually push directly to main branch, and then our changes are reflected in new versions of EasyBuild. So when I started working in INUITS, I thought when I was applying for the job, I thought I had some experience with Linux. Of course, I was a little bit of a tinkerer, but then I found out I have not too much of experience with Linux. Well, when I found out what makefiles are, what CMake is, and what pib is, how Python works. So I had to learn a whole bunch of stuff, and then I still don't think I have too much experience with Linux, to be honest. But yeah, it's been quite a fun path. So I've been asked to provide feedback for EasyBuild. So why I really love EasyBuild is because it automates some mundane, difficult, and unnecessary steps in installation process, which of course saves the HPC site administrators a lot of time. But what I, on the other hand, don't really like about it, that I am the one, as a developer, I'm the one dealing with the mundane, difficult, and unnecessary steps. And of course, on a more serious note, EasyBuild is not the most easy tool to set up and to use because of how complex and how configurable it is. So yeah, I wouldn't use it on a personal computer, but in the middle ground. So while we can say that EasyBuild is not for all kinds of users, it really is great for HPC sites. And this is a sentence that I'm particularly proud of, it, the stuff it does is too complex to be any easier. And so how exactly we contributed to EasyBuild is we have worked on approximately 210 easy configs. Also, we have made some easy blogs, and of course, also we have made some contribution to framework. And for those of you who have any idea what EasyStack is, that's something we have been working on as well. So I think that's it for my short presentation. And just in case you would ever need any help from us INUITS, please let me know. Thank you.
So we have a question for you from Kenneth.
All right.
You and your colleagues were relatively new to HPC and supercomputing when you started working on EasyBuild. What aspects did you have the most trouble with in terms of learning what you need to know?
Well, I suppose I can speak for me personally. I think installation procedures from like in various terms such as pip installation or R packages installation, of course, CMake and this sort of stuff is something that was really unknown to me. And that's something, speaking for myself, it's something that somebody had to deal with, and then I try to do it as little as possible. So obviously building stuff from source and use it and installing stuff from source, you cannot really do anything. You cannot really rely on something like that. So for me, it was the hardest part, to learn how to install stuff from source rather than just with, I don't know, Aptitude package manager or something like that.
And second part from Kenneth, the same question for EasyBuild specifically. Any specific aspects we could improve a lot on to help new people to the tool?
Well, I think that anything I say, it will be used against me because I'm going to be the one who's going to develop it. But on a serious note, I think that logging could be a little bit better, because sometimes it just throws an error which is not really intuitive, and you have to dig in a little deeper to understand what the actual problem is. Sometimes it just happened that the problem was quite easy to solve, but not too easy to decode, I would say. So maybe logging could be a little better.
Yes, yeah. I know that from part of my job is teaching people at our site how to use EasyBuild, and a lot of the time is teaching them how to read the log file to find the error to actually fix the problem that they fix in about 5 minutes when they have the error, but they don't know what the error was, and that's what takes an hour to find.
Exactly.
And Kenneth's response is along the lines of, yes, he might get you to work on that.
I'm sure.
Did anybody else have any questions for Dennis? Okay. Thank you to Dennis. I'm not seeing any more questions, so we'll say thank you and stop you there.